1, 2, 3. One, two, two. Is there sound? One. Okay. Does that look good? Что с микрофоном? What's wrong with the mic? I mean. Yes, I'm using the laptop mic. I'm not sure. I mean, I don't have any better one anyway, so I'm gonna stick with this one today. Okay, let's drop a comment. Hello. So today, the stream was announced by Code Forces, lovely there. So today I'll be doing Starking's Winter Series 2020 round 1. Okay. Yeah, I guess you can hear me touch the table, but yeah, I'm not sure that can be fixed easily. Maybe I just shouldn't touch the table. Yeah, I hear that the voice is a bit. Yeah, sure. I mean, this is the first stream, right? This is kind of test stream, so I might get a better mic later, but for today, it is what it is. And yeah, sure. So maybe I can start telling about the contest. So yeah, the series is 5 rounds long, and each round is 80 minutes long, but you can start anytime during 10 days. And I'm gonna stream live the way I'm gonna solve this contest, the first round of it. And I'm starting at almost the latest possible time. So it's not easy to just look at how I do the contest and then do it better. And yeah, the rules are a bit interesting because there are 6 problems, but the rules are similar to ICPC rules, but they're also different at the same time, because you can just use the ICPC submissions. Submissions ICPC style are called open, and you can also use submissions which are blind. A blind submission means that your solution is not tested during the contest. You only see the result after the contest. But so if it's incorrect after the contest, then you just don't have this problem solved. So it is not very profitable to make blind submissions because you risk failing a problem. But if you're 100% sure that a problem is correct, your solution is correct, then you can use a blind submission, and what you get from it is that your penalty time decreases. And the harder the problem is, the bigger decrease you get from the penalty time. So it's more profitable to make blind submissions to hard problems, but not so much for easy problems. But personally, I'm going to use the all open strategy, at least for today. In general, I just feel much more comfortable with it. And yeah, it just allows me to make submissions without thinking if it's correct or not. I'm not sure it's the best strategy in every contest of this held by these rules, but we'll see. We'll see how it works today at least. But in general, I've been doing the same for like several years anyway. So yeah, that's it about the contest. No, I'm not gonna use only blind submissions, sorry. And I guess we'll wait for, I don't know. Yeah, sure. I guess I'll wait for 5 to 10 more minutes. I don't think I will start at 21:59, because if I don't start before 22:00, then I just don't do the round. I don't want to risk that, but yeah, maybe at 21:55 is a good time. Can I maybe decrease the streaming resolution or give it a wider range? Okay, as far as I know, I cannot give it a wider range, unfortunately, because yeah, right. So it depends on the on Twitch and number of live viewers. Yeah, that's correct. Thank you, Lydia. And decreasing resolution. Yeah, I'm not sure about that. Yeah, I understand that maybe if your connection is not fast enough, then maybe you have some problems viewing it. Can you actually decrease the resolution I give out? I mean, it's kind of a compromise, right? If I just decrease the resolution, then it will be harder for people to view it. But yeah, it lags a bit. Sorry if it lags a bit, but hopefully it's still of reasonable quality. Yeah, okay, we'll wait for 5 more minutes, as I said, and then I think I'll start. So, how do you do? Tell me what you think. Is it rated? It is not rated. Will the stream be uploaded later? Yeah, I think so. I'm probably gonna upload it at YouTube so that it doesn't get lost, because Twitch doesn't save past broadcast. I think, at least it doesn't save them forever. Yeah. Also, saying about what's gonna happen today. So my current plan is just do the contest competitively right now, and after I finish all the problems or the contest ends, we will discuss the problems. I'll run through my solutions and try to explain them. Well, also translate the problems, because, as I mentioned at Codeforce, unfortunately, the problems are in Russian, so it might be hard for you if you haven't seen them before. And yeah, I'm not going to use the translator during the contest, but I will use translator before the contest to at least show the problem statements roughly and explain them as I can. And am I planning to do more of this? Well, of course it depends on the quality of what happens today. If I like it, then sure. At least we have 4 more rounds of this series, so maybe I'll do 4 more if I really like. But in general, you're asking about YouTube streams like Piotr Omnik, etc. But they are not really streaming, right? They are just doing screencasts. I'm not so excited about the idea of screencasts, but yeah, so I want to try streaming it actually, and there are not a lot of strings you can stream. You cannot stream real contests, right? Those which are going online, like Code Forces rounds. And yeah, and then it's not competitive enough to just do the past contests, past rounds, just do them virtually. I don't feel like that too much. And this series is kind of a compromise between competitiveness and being online. And we'll see how it goes. I will not look at the chat during the contest, so feel free to discuss what's going on. Hopefully the stream is going to be okay, and if anything goes wrong, hopefully I will get notified. Viewer donation blind submissions. Okay, I'll definitely consider that. Oh, what do I know about judging? No, I don't. What was with Goodbye 2019 at Cold Fortress? Okay, I mean, I was just trying to solve problem G for a long time and I just couldn't. That's kind of unfortunate, but it happens, I guess. Okay, let's see. Okay, maybe I should start a bit later than 21:55. Nice haircut, thank you. Please play Minecraft now. Will I compete in Bubble Cup? It's very good competition. I don't know, if I encounter some kind of announcement, then maybe. But I have actually kind of missed it every time. But I mean, it's a mirror is still held at Cold Force, right? I guess it's fine for me. But maybe I should do the actual competition. Don't forget to press a record button in OBS. You mean start recording? So I will be recording and streaming at the same time? Okay, let's see. I mean, okay. How would I rate the difficulty of this contest? I think it's gonna be easier than usual Cold Forces Division 1. But we'll see. Okay, so one final maybe note there is that Dominic is well is interested in doing live commentary of me doing the contest. So I'm not sure about the link. I'm not sure where you can see the live stream, but his plan was to do live watching me doing the contest and commentating, and then yeah, I mean, maybe ask him about the link. Maybe. Which one? One. Okay, so here's the link. So yeah, so feel free to watch that broadcast as well. At least while I'm doing the actual competition, and I guess you might want to return after it. But yeah, you also feel free to view both of them. I'm not sure. Up to you. So we have 2.5 minutes before the end, or before the start. just start. Okay. Oh yeah, I actually have this one. Okay. Oh, let's see. Okay, maybe it works. Okay, let's go. So I will post the chat now and start. Mhm. Let's go. I should just uninstall this one. Stop! No! Don't. Thank you. GG. Was the stream alright? Was it okay? I didn't get any notifications, so I suppose. I was 3 minutes away from winning this. Isn't it spoilers? Okay. Yeah, okay, so I guess that the problem is that, yeah, all my submissions are open. So as you can see at the scoreboard, these submissions, if they're all correct, they also give some decrease in penalty, like minus 21. Yeah, actually it even has a suggestion. Yeah, and yeah, so this problem is minus like negative 76 minutes. That's quite a lot. Yeah, so that's how you get negative penalty. But we'll get to know at the end of the contest if all those submissions are correct. If I could just comment a bit during the coding, it would be fair. Okay, thank you. I mean, it's a bit hard to talk while coding. I'm just afraid that it would not be like it would either be not comprehensive at all. I would just be murmuring to myself, or it would take enough time. If it takes enough time, then I perform worse, obviously. But maybe that's fine. I can afford that. Right? So this contest was. Yeah, should we discuss the problems? Actually, yeah. 222, 33 to do. Okay. Did anyone watch Omnic's live commentary? Was it a thing? Awesome initiatives, thank you. Can you please change your camera angle? Okay. Basically, the thing is, I'm using the built-in camera of Dell XPS 13, and this is like the only laptop I've ever seen, I think, that uses the camera right like in the bottom left corner of the screen. And yeah, so basically just because the screen is built in such a way that the camera is not in the very nice place. So yeah, I mean that can be like if I use another web camera, just an outer one, then it should be okay. How to use for editor? Can we see our setup? Okay. I mean, you have seen my set. I guess you saw my setup for the whole contest, right? So basically, I have a browser and I have Farm Manager. In Farm Manager, oh yeah, I also have Paint. Paint is nice. I guess I should use something else, but anything anyway. It didn't struck me too much. So yeah. Here yeah, basically this contest was like the perfect showdown of library usage, because the problems were quite, I don't know, heavy on implementation, and in general that's I think that's a correct like trait of snorkeling series, I think. It's in general pretty implementation heavy. So my laptop, as I said, is Dell XPS 13, and yeah, the sound is a bit lagging. I heard you. Unfortunately, I can't do much now. Hopefully that's still fine. I mean, I guess I have to use an outer microphone. So yeah, it's fixed now. Thank you, but I didn't do anything. That's the thing. Maybe that's just about internet connection. So I am using Farm Manager, and the plugin I use for pasting algorithms it's called True Template, I think. Actually, I just set up it once, and it was suggested to me by Vladimir Smakalov, who was also using it. It's pretty nice in general. It just allows you to insert something quickly, but I guess that if you use any IDE, any like real IDE, then it would have like live templates or something like that out of the box. So this is not totally necessary to use Farm Manager or whatever. I mean, in general, it just doesn't matter too much what setup you use. It's just up to you. And I think it doesn't affect your performance too much. So, why do I generally prefer Windows over Linux? Just the habit, I guess. I'm just used to using Windows. Sometimes when I need some kind of Linux stuff, I could use WSL built into Windows 10. It's pretty nice. I would recommend, but it lacks some feature though. Okay, so should we discuss the problems? Would you like to hear the solutions? Or maybe you know them. If you just know all of them, then it's fine. Okay, I guess I will run through the problems. Also, it's interesting about the results, I still don't know them. So, the first problem F. Oh, okay. GitHub repo. Okay. In general, I'm not even sure my repo is any like useful, but okay, let's discuss the problems from the easier ones. So there are no in English, but still you can use some kind of translation. What this is going on? Okay. I guess if you watch my stream, then you already know that something's wrong. Yeah, sure, I will state the problem statements. So in problem F, we had basically the problem was we generate k random integers. Each random integer is from 1 to n, and we are kind of like playing a game as the attackers. So the game is we are offered an integer, and if it is if it satisfies us, then we can just take it, keep it, and that's our score. Or the other option is to discard the integer, and if we discard an integer, then we are just offered the next one. But we cannot discard the integer more than k minus 1 times. So we can, if we get the case integer, we have to pick it. And the question is, what is the expected value of integer we get? No, yeah, integer we get. So the solution was pretty short. Here it is. Basically, it's kind of using DP. So the question is, what is like the only thing that interests us over the last integers? Like, let's say we discard an integer, or we can pick it, right? The question is, what is the expected value we get if we discard? So to make a decision whether we discard or choose it or pick it, okay, sorry, I get a bit distracted, but basically the question is f of km expected value. So this is the answer to the problem. So this is what we want to find. We are asked fkm. And I claim that the solution is if we just sum it over I from 1 to n, what do we sum here? And the thing we sum here is maximum of I and whatever we get if we discard the number. And if we discard the number, we get f k minus 1 n again. And this should be not the sum, but the average. So we divide the sum by n. So I just say that this is the formula. This is the formula. And yeah, that's my solution is just implementing this formula in a short way. And also, I guess, f0 is equal to 0. So, yeah. So basically, that's it. We are just, yeah, it's using expected value concept. So we only want to know the expected value we get if we discard. We don't want to know every possible scenario. We just need the average. And when we are offered an integer, we just compare it to the average we will get. And just take the maximum. Basically, that's it. That's all for problem F, I think. So let's move on. The next problem D. In problem D, we had times the index is okay. So this is problem D. Basically, the problem asks for the number of sequences of integers of length n. Each integer is between 1 and k. And a sequence is called bad if there exists a pair of numbers a and b, so that sum of integers at positions a and b minus 1 is equal to the sum of integers in positions b and a plus 1. So basically that's it. So you need to count the number of sequences that have at least one such pair. The first and the last insight is that, well, not the last one for sure, but an important observation is that, yeah, if I put the if I write this equation as differences, so this is ci minus ci plus 1 equal to cb minus cb minus 1, then each, like, we are only in differences of neighboring elements. And the sequence is bad if we have two equal differences. That's one observation. And another observation is that k is a small integer. It's up to 10. So the range of differences is not so high. It's not so large. So the range is between minus k plus 1 and k minus 1. So we have at most 2k minus 1 unique differences. That also means that good sequence has length at most 2k. Because if the sequence has too many integers, then we cannot have all unique differences. We will have two equal differences. So now we can only restrict our attention to small values of n up to many, actually. And how to count these sequences? It's just doing bit mask dp. And the dp is as follows. So the state of this dp is position, mask, and last. So position is how many integers we have already put in our sequence. Mask is what differences we have already used. So mask has size k minus 1, and last is the last integer, like the position at position pos. And then the transition is just like loop over the next integer. It's called t in my code, and just do some transition. Like, yeah, if you have, we need to remember the previous integer so that we know the difference between the next one and this one. And we can also check in the bit mask if this integer already was used. And then, yeah, basically that's it. So that was problem D. Problem B was the next one. In problem B, we had a matrix of characters. The statement is kind of long, but it's like a bit too complicated, I think. So the problem is we have a matrix of characters. It's 4 by 4 in this case, and we have a string length 3. In one step, we can choose any column and rotate it, like change it into its cyclic shift, like shifted by 1. And we want to find this string in the matrix at some position. So it should be a substring of some row of the matrix. And we want to make as few cyclic shifts of columns as possible. So here the solution is, let's say we know the position where our string occurs eventually. So suppose we know that it occurs at position like in row I, starting from column J. In my solution is here. So this is where I just loop over all positions where the string can occur. And then we want to shift every column so that we get the letter we need at the position we need. So for each position, for each column from J to J plus len, where len is the length of the string, we just need to find the next occurrence of character, corresponding character, in the matrix somewhere below it. Well, in a cyclic fashion. And if we can find the next character quickly, then we have solved the problem in cubic time, and that's totally fine. So the question is how do we find the next character, and we can just find the next character. We can just recompute all the next characters in advance. So for each column, we just make a linear sweep line, like something like that, and yeah, first I find the first occurrence of each character in the column, and then I go from bottom to top and update the arrays as we go. So basically, this is kind of standard technique. So yeah, I guess I will go too much in depth here. I'm actually not sure about what we should discuss. What are the results? They're not available yet. We'll find out in 2 minutes. So yeah, I'm not sure how level this should be. Okay. So this was problem B. The next problem is problem C. In problem C, we have to draw again, this problem statement is quite. The problem is we have endpoints and we need to find points so that the distance, no, not the distance, so that after we separate the set of given points into the set of points closer to point 1 from the output and the set of points closer to point 2 from the output, we want these sets to be equal. We are allowing at most one point to be equidistant from both. Make quality, yeah, sorry. Okay. So the question is, how do we draw a, like, yeah, so we are, if the number of points is even, then we want the null points to be equidistant from A and B, and if the number of points is odd, then we want exactly 1 point to be equidistant from A and B. So the solution basically is as follows. We just sort the points lexicographically. I'm using my paint skills now. Okay, so imagine these are points. So I sort the points. So this is point 1 after that, this is point 2, this is point 3, this is point 4. Let's say the number of points is odd. This is point 5, this is point 6, this is point 7. So what I do is I take the point which has the median in number. So the middle point is 4 in this case. And I draw a vertical line, but not exactly vertical. The line will look like this. So it will be almost vertical, but the goal is to have all points that are graphically smaller than this to be on the left side and all the other points to be on the right side. So what I do is I just draw this line, dividing line. I just pick this point, and the other point has x coordinate 1 smaller and y coordinate. This is how I draw the dividing line. And you have the next number of points is even, but it's still doable. And when we find the dividing line, the only thing we have to do is to find 2 points that are equidistant to this line, and we have just to output these 2 points. And then the rest is just finding the coordinates carefully. That's it. So, what are the results? Yay! I won. Cool. It was close though. Oh, I had 2 failed problems. That's sad. And you can one. Beautiful one. Even though Dominic had one blind submission. He got 69 less penalty. We still didn't have enough time. Okay, maybe yeah, so basically that's the cost of just doing the all open strategy. I guess I could have easily lost this one, but yeah, I didn't. Yeah, so in the next two problems, I had oh, these two are quite complicated. So the next problem was oh, let's see. Basically, we have n strings and we have a signature string. The n strings are initially empty, and the signature string is given in advance. So in the test case, we can see that this is the signature string, for example, and then we have 5 empty strings initially. And then we have 5 queries. Each query has one of two types. One type is type 1. Type 1 query is basically we are given a range of indices in the string. No, this is one type. Yeah, the range of indices. So in this case, for example, we add the string to like, yeah, the range is all strings from 1 to 5. And then we have the next string, like the string is given, which is appended to every string from the set, like from the range. So we just append a short string of length at most 10 to each string in the range. And then second type query is we are given a range of strings, in string indices, and we want to find the number of strings in this range that have the signature string as its suffix. And we need to output this number, the number of strings that have the signature string as its suffix. And the signature string is 20 characters long. We have 10 to the power of 5 strings and queries. And each appended string is a set of length at most 10. So this is somewhat standard, I don't know, segment tree problem, I guess. So the only question is how we handle the changes. And the question is actually what information we need to store for each string and like what is sufficient. And if you know the usual like string search algorithm by Knut, Morris, and Brett, you kind of understand that we can build like an automaton on like prefix function. Basically, the thing is when we are looking for a signature string in some different long string, at every position we are only interested in some one integer like k. So basically, I guess I can show this one. So we have this is the algo. So yeah, so k is the length of the longest suffix that is equal to like, no, this is search. So for each position in the string where we're in this case we are looking for string s in string w as a substring. So we have already built the KMP table, prefix function table for string s, and then for each position of the big string, we find the integer k, which is equal to the length of the longest suffix of w in this position, which is equal to the longest prefix of s. And whenever this length is equal to the length of the whole string s, then we have found an occurrence. That's basically how this algorithm works. And we only need to know the position, like the value of k is only is the only thing that translates our state at every position. And basically, the problem asks if we have a signature string as a suffix. And this happens whenever k is equal to n in this algorithm. So we will only store one integer for each position. It will be from 0 to the length of signature. This is corresponding to this k. So as length of signature is at most 20, we only have each integer is between 0 and 20 at most, so it's a small integer. But the question is, how do we handle range queries? And to handle range queries, it's a bit complicated, but basically we have some kind of segment tree, but in each node of segment tree we maintain like the function of transformation of the value of k. At this point, actually, I am wondering who is the target audience for this explanation, and if anyone is listening. But I guess I can just throw in some random words. So in this case, we can handle the queries by segment tree. We maintain the transformation function for each value of k. Func k is what value of k we will like if we add those strings, if we append the strings that we append, then this is the integer to which each value transforms. So CNT is the number of values in the range, and in the end, the CNT of the last position length of signature is what we want, and add is just the lazy propagation tag. Basically, again, it's a function which you have to apply to all children in our segment tree. And then it's kind of standard. Yeah, so roughly that's it. I guess I will not go into much details because to explain all this problem in full, it would take a lot of time, but I'm just not sure if who will be benefiting from this. Because if you understand the solution, then probably you don't need half an hour more, and if you don't, then you need more than half an hour. So for now, I'm not sure, but I will go through the solutions anyway. Finally, in problem E, the too difficult solution. And as it was suggested in the chat, there's a simpler one. So the problem is we have a tree on n vertices and we have a permutation of the vertices, and we need to divide this permutation into k segments, so that on each segment, if we find the least common ancestor of vertices on this segment, the sum of their depths is as small as possible. And the easy solution, which I didn't notice, is, well, the easiest solution, which is too slow, is just doing dp. So the easiest solution is just do dp. The ij is smallest sum of depths of LCAs when we divide the first I integers of the permutation into j segments. And the transitions are just over k equal to I plus 1, I plus 2, and so on, and move into dp k j plus 1, this is how we usually do the dp forward transitions, and here we have dp ij plus lca of p I plus 1 p I plus 2, so on, p. Yeah, so this is the easiest solution, and the solution is n k square. It's actually n square. K is different here. This is t. So this is n squared k. The constraints are constraints 1 less than k less than 300,000, and n multiplied n times k is at most 300,000. So nk solution would be fine, but n squared k solution is too slow. So the question is how to optimize it, and I went for a very complicated way, but it's kind of technical. So in particular, if we wanted to find the maximum sum of depths, like the largest sum of depths, not the smallest sum of depths, my solution would be easy to handle this case as well. Like it would be easy in my solution, just do the same, just find the maximum instead of minimum. So my solution is too general, but the easiest solution is to notice that whenever we have LCA, pi plus 1, pi plus 2, and so on, pt, we have a lot of vertices. Let's say we have vertices v1 and v2, vt, is equal to LCA v1, v2, or LCA v2, v3, or and so on, or LCA v minus 1, vt. Something like that. And basically, or corresponds to choose one with small steps. So when I want to find LCA of a lot of vertices in a tree, we can just find LCAs of neighboring ones and just pick the minimum depths of the LCAs of neighboring ones. That's a useful trick, which I forgot about. And if we notice this, then the problem suddenly becomes very easy. We just, so every LCA on the range we divide our representation into is either just one vertex, if this range is just one vertex of length, like of length 1, or it's some LCA of two neighboring vertices. And we can notice that we just have to pick out of our permutation of length n, we have to pick out of permutation of length n, pick k segments, pick k pairs pi plus 1, or just individual integers pi. So we have k in total, either pairs or individual integers, and we want the sum of depths of LCA of pairs plus depths of individual integers to be minimized. And then we haven't actually divided our permutation into k segments. We have just found k small segments of length 1 or 2, but they don't necessarily, they should be all non-intersecting. So we don't need all of them to cover the whole sequence, because when we have chosen them, like the short segment, which are responsible for our LCAs, we can just expand the segments so that they will cover all the permutation. And now we just do some kind of easy dp. It will be just dp new ij. It will be smallest answer when we picked j pairs or integers from pi, and transitions are to dp new I plus 1j if we just ignore integer I, to dp new I plus 1j plus 1 if we pick pi, or to dp new I plus 2 g plus 1 if we pick a pair 1 plus b. And yeah, this is finally all of NP. Hopefully that was understandable enough, like even if you are not into like hard solutions. So yeah, I just tried to explain it as I can, but I don't know if it was good enough. So yeah, the question is, I have discussed all the problems. Was it useful? And what should we do next? Do you have any suggestions? I guess we will please consider uploading this to YouTube later. Yes, sure, I will. Okay, so we had some questions here. So yeah, the questions about the setup I just showed you, and the library is indeed very useful in this contest in particular. In general, it's not like super useful in contests like on average. Maybe I'm wrong. I'm not sure. At least if you do 8-quarter contest, then usually you do not use your library except for the modular integer. But yes, from time to time you need some kind of segment tree or like LCA, and I'm just lazy to type them. I could do that, but they just cost time. Basically, it's like known that Omnic is not using pre-written code, and I would assume that he didn't use pre-written code in this contest either. So it's indeed super like impressive that he solved all the problems without using the library, but I used a lot of my library. So I guess if we were in equal conditions, if I was not allowed to use the library, then perhaps I would lose this one on time, on penalty, but I'm not sure. It depends. So anyway, good job. Please say some words why it is true that LCA equal to LCA or less LCA. Yeah, sure. So, well, it's a bit, yeah, so let's just talk about this equation, I guess. So, basically consider a tree. Let's say we have a tree. Yeah, again, painting, I guess. Maybe if I use some kind of graphical table, this will be fine. But in general, let's say we have some tree. We have some subtrees here. This is a subtree. This is a subtree too. And let's say that this vertex is the LCA of some vertices. Let's say these vertices are like in here. Like we have some vertices here, 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 here. And we have some set of vertices, and this is like the LCA of all these vertices is this vertex. And we can know that actually if we pick LCA of any two of these vertices, there are two cases. For example, LCA of two vertices in different subtrees in this picture. For example, of the leftmost and rightmost vertices, their LCA is just the green vertex. If we just consider, like, for example, this one and this one, their LCA is just the green vertex. And if we pick two vertices in the same subtree, let's say this one again and this one, then their LCA is somewhere inside the subtree, but we don't really care where. But the main thing is that we always have two vertices. If we just traverse the vertices from the first one to the last one, at some point we will move between subtrees for sure. And then we'll get the LCA equal to the green vertex. So that's basically the explanation of why this fact is true. Was it clear? Do you have any other questions? Actually, yeah, I mean, I would like to hear your suggestions on the format of the stream. So this is what we did. like let me know for sure what you found exciting. I guess we will wrap it up soon. So make sure to comment code forces maybe, or yeah, just in comments. Yeah, sure. So the question is what format we should use. So the first part was just doing the contest, and the second part was explaining the problems. Make sure to tell me what you found exciting and what not so much. So thank you all for watching. Yeah, mic or sound has some tech issues. I will try to fix them before doing another stream. Connect with cable for more stable connection. Suggestion, blind submit. Okay. Blind submit for donating, I guess. So this actually the second round of SNWS series is already running, so the rounds are intersecting, and this one runs from the 8th of January to the 17th of January, and today is 12th of January. So perhaps I can do the second round in the same format on the 17th of January. Let me know if you're excited about that. That's gonna be in 5 days. So yeah, perhaps I will do another stream in 5 days. And I guess that's all for today. So again, thank you. Okay, do contests with English statements, please. The thing is, what should be the contests? Like what should be those contests? That's like the main question. Because it's not obvious. For example, if we just do I cannot do live contests like at Codeforces or at Coder. But just doing past contests virtually is not like exciting enough for me, at least for now. And this contest is at least a real one, but it's also virtual, so I can just do it after everyone else does it. And so it just like satisfies both conditions. Yeah, someone says it. Yeah, I guess it's harder to understand the statements just on the go, just as I explained them. It could be a bit tough to understand them. But what you can do, as I said in the Codeforces announcement, is that you can just read the problems beforehand if you just start the virtual contest and just use automatic translator. You can just read the statements beforehand, and you don't even have to like think about them or like solve them. You can still watch the stream, and I guess you will have more understanding of what's going on. Even if you don't understand Russian, should be fine. Contest links will be added, and can you do IOI problems? I guess I've done almost all of them, and just doing like already. Solve lead code hard problems. I've never done lead code at all. Okay, so let's wrap it up here. Thanks all for watching. I hope you enjoyed the stream, and see you later, hopefully. For example, in 5 days. Okay, see you. Thank you.